The Sun. A blazing ball of plasma that dominates our sky, the Sun is the heart of our solar system. It provides the light and warmth that sustains life on Earth, making our planet a haven for diverse ecosystems. But don't let its familiar presence fool you. The Sun is far more complex and dynamic than it appears. The Sun is a churning, violent giant, constantly in a state of flux. It's a cosmic inferno fueled by the forces of nuclear fusion, where hydrogen atoms merge to form helium, releasing immense energy. Its surface writhes with magnetic storms and eruptions that dwarf our planet, creating a spectacle of cosmic fireworks. The Sun is not a solid mass. It's a vast, seething sphere of plasma. It's not even a ball of fire in the traditional sense. Instead, it's a giant sphere of plasma. Plasma is a superheated state of matter, where temperatures soar to millions of degrees. Think of it as a gas where the atoms have been ripped apart, creating a chaotic environment. In this state, electrons break free from their atomic nuclei, creating a sea of charged particles. These charged particles interact with magnetic fields, driving the Sun's dynamic behavior. This plasma churns and flows within the Sun, driven by intense heat and magnetic fields. It creates a dynamic and ever-changing environment, with magnetic fields twisting and snapping like cosmic rubber bands. Giant loops of plasma, called prominences, rise and fall on the solar surface, sometimes extending thousands of miles into space. Solar flares, sudden bursts of energy, erupt with the force of billions of atomic bombs, releasing radiation across the solar system. The Sun is a constant reminder of the immense power that exists in our universe, a power that shapes our very existence. Understanding its violent nature is crucial to appreciating its life-giving energy and the delicate balance it maintains. But it's also essential for protecting our technology-dependent world from the Sun's occasional temper tantrums, which can disrupt satellites and power grids. Deep within the Sun's core, a cosmic dance is taking place. This is not just any dance, but a powerful and intricate ballet that has been ongoing for billions of years. It's a dance of atoms, a relentless ballet of fusion that powers our star. At the heart of this dance, hydrogen atoms are the main performers, constantly colliding and merging. Under unimaginable pressure and heat, hydrogen atoms collide. The core's temperature reaches about 15 million degrees Celsius, creating an environment where these collisions are inevitable. They fuse together, creating helium and releasing a tremendous amount of energy. This energy is in the form of light and heat, which eventually makes its way to the surface of the Sun. This process, called nuclear fusion, is the engine of the Sun. It's the fundamental reaction that has kept our star burning brightly for over 4.5 billion years. Every second, millions of tons of hydrogen are converted into helium. This conversion releases an immense amount of energy, enough to power the entire solar system. The energy released from these reactions is what gives the Sun its light, heat, and life-giving energy. Without this continuous fusion, life on Earth would not be possible. It's the same process that powers hydrogen bombs, but on a scale that's hard to fathom. The Sun's fusion reactions are far more controlled and sustained. Imagine the power of millions of hydrogen bombs exploding every second. This gives us a glimpse into the sheer magnitude of the Sun's energy production. That's the scale of the nuclear fusion happening within the Sun. It's a continuous, unstoppable process that defines the very nature of our star. The energy generated in the core makes its way to the surface. This journey is not a quick one. It takes hundreds of thousands of years for the energy to travel from the core to the outer layers. This journey takes hundreds of thousands of years. Along the way, the energy is absorbed and re-emitted countless times, gradually making its way to the surface. Along the way, it heats the Sun's outer layers, creating the intense temperatures we feel on Earth. The surface of the Sun, known as the photosphere, reaches temperatures of about 5,500 degrees Celsius. The Sun's core is a furnace unlike any other. It's a place where the fundamental forces of nature come together to create and sustain life. It's a place where matter is transformed, energy is unleashed, and the very building blocks of the universe are forged. The core is the heart of the Sun, driving its every heartbeat. Studying this process helps us understand not only our own star but also the life cycle of stars throughout the cosmos. By learning about the Sun, we gain insights into the workings of the universe itself. If you could travel to the Sun, the first thing you'd encounter is the photosphere. This is the visible surface of the Sun, the part we see from Earth. But don't let its familiar appearance fool you. The photosphere is a roiling ocean of plasma, heated to a scorching 10,000 degrees Fahrenheit. Imagine a sea of molten gold, constantly bubbling and churning. That's what the photosphere is like. It's made up of countless granules, each one a cell of rising and falling plasma. These granules give the photosphere a grainy appearance, like a giant pot of boiling water. But the photosphere is more than just a pretty face. It's also the source of the sun's light and heat. The energy generated in the core finally escapes from the photosphere, radiating out into space. This energy travels through the solar system, reaching Earth and sustaining life. The photosphere is a dynamic and ever-changing environment. It's constantly being shaped by the sun's magnetic fields. Sunspots, those dark blemishes on the solar surface, are cooler regions caused by intense magnetic activity. Section 4. Solar wind, a constant stellar storm. The sun is constantly emitting a stream of charged particles, a phenomenon that has fascinated scientists for decades. This stream, known as the solar wind, flows outward from the sun at speeds of over 1,000,000 miles per hour, carrying with it a torrent of energy and matter. It's a constant storm of plasma that permeates the entire solar system, influencing everything in its path. Imagine a giant fan, constantly blowing a stream of air. This analogy helps us understand the relentless nature of the solar wind. That's what the solar wind is like, but instead of air, it's made up of electrons, protons, and other charged particles, all moving at incredible speeds. This stream of charged particles carries the sun's magnetic field far out into space, creating what we call the heliosphere, a vast bubble that envelops our solar system. The solar wind has a profound impact on the planets in the solar system, shaping their atmospheres and magnetic environments. It can strip away atmospheres, erode surfaces, and even spark auroras, those beautiful light displays we see near the poles. Here on Earth, our magnetic field acts as a shield, deflecting most of the solar wind and protecting us from its potentially harmful effects. But it can still disrupt satellites, power grids, and even radio communications, causing significant challenges for our technology-dependent society. Understanding the solar wind is crucial for protecting our technology and exploring space. Scientists are working tirelessly to study this phenomenon. It's a powerful force that we're only beginning to understand, and each new discovery brings us closer to unlocking its mysteries. But by studying its behavior, we can learn more about the sun's influence on our planet and the solar system as a whole, paving the way for future space exploration and technological advancements. Section 5. Parker Solar Probe. Touching the sun. To unlock the secrets of the solar wind, we need to get up close and personal with the sun. That's where the Parker Solar Probe comes in. This groundbreaking mission, launched in 2018, is sending a spacecraft closer to the sun than ever before. The Parker Solar Probe is a technological marvel. It's built to withstand the extreme heat and radiation of the sun's corona, the outermost layer of the solar atmosphere. The probe will zip through the corona at speeds of over 400,000 miles per hour, making it the fastest human-made object ever built. Imagine a tiny spaceship braving the fires of hell to unlock the secrets of the sun. That's the Parker Solar Probe. It carries a suite of instruments designed to measure the properties of the solar wind, study the sun's magnetic field, and capture images of the corona. The data collected by the Parker Solar Probe is revolutionizing our understanding of the sun. It's giving us unprecedented insights into the processes that drive the solar wind and its impact on the solar system. This mission is truly pushing the boundaries of space exploration.